Okay, so today we're going to look at section 11.8, which is finding areas. And all the integration techniques that you've learned in this chapter, you're going to have to apply them now to find area under the curves. And from book 1, you know why integration is used to find area under curves, okay? But in this book, and in this chapter, basically, you are now going to be meeting really quite complicated functions rather than the easy ones that you met in book 1. Okay, so the first example is on page 313. This is the function that you've been given, and also a diagram has also been given. Now, the diagram is not always given in your exam questions when it comes to questions like finding area under the curves. Okay, and this question is also a little bit simpler in the fact that it's, you've been given you've been given this limit. You've also been given this coordinate. Okay, now obviously the limits are mostly given, not always, but this coordinate is not always given, and sometimes you have to find that out by yourself. Okay, but this question makes it a little bit easier in the fact that it's given to us. So basically it says use integration to find the area of this region which is shaded R. Okay, so all we have to then do is we've just got to integrate this function with respect to x. Okay, so I am going to take my constant out and I am going to write my power as a negative power, just like that. And then what's going to happen is I am going to use my chain rule. Okay, now the chain rule I am going to use, but I'm not going to do it with the u and u, etc. I'm just going to show you how to do that faster than that. So basically you've got what we've got here is we've got a function inside another function. Okay, so what we do is we just add 1 to this power. You're going to have a half, okay, and you're going to divide it by the new power. So if you're dividing by half, you're actually essentially multiplying by 2, and then what you'll do is you'll also divide by the derivative of this inside function, okay, and that derivative is 3. And there we have it. We have now got the integral of this, and we are integrating this between 0 and 4. Okay, so if we tidy this up, we are going to get 6, okay, because this gets cancelled out. You got 6 bracket 4 plus 3x to the power of a half, and you are inputting the limits for 0, okay, and if you input those limits using your calculator or by hand, you should get 12 units squared for your answer there. Okay, so that's the first example. Okay, this example is now, what we have here is we've got two curves and we've got to find the area that is between the two curves, okay? So now the method for that is that you basically integrate the function that is, okay, because that's the one that is going to give you a greater amount of area underneath that function. So here you've got two curves. Even if you had, like, let's say a curve and a line, so whatever function is on the top, what you do is you subtract the one that's under from the one that's over. So this is the general formula for those, okay, so this is the general formula for area between two functions, and fx function is always the one on the top, okay, gx function is always the one at the bottom. Now if we look at the example that you've got on page 314, your fx function has been described as sine 2x, and your gx function has been described as sine x cos squared x. Okay, and we've got to find the area between the two curves from 0 to pi over 2. So by using this formula on top, and making sure that sine 2x is the function that I've got on the top, is the top curve. Then my method is going to be sine 2x minus sine x cos squared x dx between 0 and pi by 2. Okay, so if I integrated that, now if I integrate sine 2x, I'm going to get minus 1 over 2 cos 2x. And if I integrate sine x cos squared x, then I'm using the reverse chain rule, or actually I'm using substitution, because I've got cos squared x and that is being multiplied by its derivative. Okay, so I will use substitution for this, and you've done this in exercise. Let me just tell you exactly where you learned this so you can jog your memories a little bit. You did this on page 303, and you also actually did this. I used this method, the reverse chain rule method, on page 301 for this exact same example, for exact same integral. Okay, so you can use reverse chain rule or substitution to integrate this. Okay, but if you did that, you would actually get minus 1 over 3 cos cubed x. Okay, and you're integrating that between 0 and pi by 2, and if you substitute it in your limits, you would get 2/3 units squared. Okay.